Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 30 problem of this month on LeetCode. Before starting, if you guys haven't subscribed to my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 2221. Find triangular sum of an array. Right. So I'm going to solve this problem using two approaches. So in first approach, that is going to be just a brute force, and I'm going to solve this problem in O of n square time complexity. And the second approach, I'm going to solve it using binomial coefficient, and we will be able to solve that problem in O of n time complexity, right? So first approach is very easy. So let's first read the problem statement, and then we will solve this with approach 1, and then we will move to approach 2, right? So here you are given a 0 indexed integer array nums, where nums of I is a digit between 0 and 9 inclusive. The triangular sum of nums is the value of the only element present in nums after the following process terminates. So first is let nums comprise of n elements. So if n is equal to 1, only one element is there, then we have to end the process, right? Otherwise we have to create a new 0 indexed integer array, new nums of length n minus 1, right? And for each index I, where I is less than equal to 0 and I is less than n minus 1, we have to assign the value of new nums of I as nums of I plus nums of I plus 1, and then we have to do the modulus with 10, right? And then we have to replace the array nums with the new nums, and we have to repeat the entire process starting from step 1 until we get only one element. Okay, so in the end we have to just return the triangular sum of nums. So very easy problem statement, right? So O of n square solution is very easy. So let's understand that solution. So this is how nums are given to us, right? So total 5 elements are there, right? So initially 5 elements are there. In the next step we have 4. In the next step, if you see, we have 3. In the next step we have 2, and in the last step we have just 1. So we have to stop here. And what is the value here? 8. This is what we need to return, right? So now this is your nums array, right? 1 2 3 4 5, right? So here 1 and 2 summation is 3 modulus 10 is 3, 2 and 3 summation is 5 modulus with the 10 is 5, 3 4 7 modulus 10 is 7, 4 plus 5 9 modulus 10 is nothing but 9. Now here 3 and 5, 3 plus 5 is 8 modulus with the 10 is 8, 5 plus 7 is 12 modulus with the 10 is 2, right? Remainder 7 plus 9 is 16 modulus with 10 is nothing but 6, remainder, right? 8 plus 2 is 10, so 10 modulus 10 is 0 remainder. Here 6 plus 2 is 8, right? And 8 modulus with 10 is 8, and 0 plus 8 is 8 modulus with 10 is 8. That's it. So this is what we need to return, right? So what I'm going to do here, I'm going to fix my j here, let's say, right? For very first time my j is here. Then I'm just going to iterate over all the elements less than j, right? I'm going to check this. I'm at this particular index, let's say, and at this particular index I will do 1 plus 2, right? I'm going to get this. Then when I'm at this index I will do 2 plus 3, I will get this. Then when I'm at this position I will do 3 plus 4, and I'm going to get this. When I'm at this particular position I will do 4 plus 5, and I will get 9. So until here only, less than j, right? So I'm going to get this, right? In the next step I'm going to fix this as my j, and if I fix this as my j, let me use this blue color pen. So now I'm going to fix this as here my j, right? So if my j is here, so now I will do just 3. I'm here, so I will do 3 plus 5, I will get it. I'm here, I will do 5 plus 7, 12 modulus with 10 is 2, I'm getting here. Then I'm here, then 7 plus 9 is 16, I will get here. Done. Now I'm going to fix my j here, right? J here. And then if my j is here, then here I have to check this first. 8 plus 2, I will get 10 modulus 10 0, right? Then here I'm going to check this. So 2 plus 6 8, and I'm going to get this. Then I'm fixing my j here. So if I'm fixing j here, then only for this position I have to update some value. So 0 plus 8 8, right? That's it. So here one j loop is running, right? And one I loop is running, right? So j's loop, I'm starting from this last position, right? And I'm stopping here, because if I stop my j here, then in the end I'm going to get just one element, right? So let's write the code. Very simple. This approach 1 is not complex, right? So now let's write the code for approach 1. So here, first thing that you need to do here, just calculate the length of your nums array. Int n is equal to nums dot length, right? This is done. Then after that you have to just run 2 loops, right? Int j is starting from n minus 1, and here I told you that j is going to be greater than 0, and j minus we have to do. And here after this, here we have to iterate over all the elements. I is equal to 0, and I is less than j, and I plus plus, right? I'm not creating any new array. I'm just simply going to update this nums only. So that is the benefit of this. So space complexity is going to be constant 1 only, right? So here nums of I value, I'm going to update this nums of I value as nothing but nums of I, and here plus nums of I plus 1, right? And here I will just do the modulo with 10, right? This is given in problem statement. So here modulo with 10, that's it. So this is how I'm going to operate, and in the end I will just simply return the value which is at 0 index in this nums, right? So that's it. Now let's run the code and see. So see, all the test cases has been accepted, right? Now let's submit it. So see, our solution is accepted, right? So here, let me bring it here. So see, our solution is accepted, right? Let me remove it. Now it's logging out, right? So our solution is accepted, right? So this is nothing but approach one. So in approach one, we are running two loops, right? This and this. So time complexity is of n square, right? Now can we solve this problem in of n, right? So let's see that. So let's move to our approach 2. Okay, approach 2, right? So here in approach 2, if you see, we have these many numbers 1 2 3 4 5, right? Oh, this number. So here let me write 1 2 3 4 5, right? So here how we are doing, how we are solving this, right? So this is first step, right? In the next step, what I'm doing, I'm writing the numbers like this: 1 plus 2, right? And 2 plus 3, and here I'm writing 3 plus 4, and here I'm writing 4 plus 5, right? This is how we are solving. So here 3 5 7 and 9. So here if you see, here 3 5 7 9, right? This is how we are doing, right? So here same way, in the next step, I'm going to write it like this: 1 plus 2 plus 2 plus 3 here, right? That is nothing but summation of these two, right? Now I have to do the summation of these two. So here I'm going to write 2 plus 3 plus 3 plus 4, done. Now I have to do the summation of these two, right? So here I'm going to write 3 plus 4 plus 4 plus 5. This is done. So here 2 plus 2 is nothing but 4. 4 plus 3 7 8. So we are going to get 8 here. Same way here 3 4 5 8 and 12. So 12 means 2 only, right? So here if you see 8 and 2, and here we are going to get 16. 16 modulus with 10 with 6, right? But here I'm just doing the summation right now, right? So here we are getting 16 as of now, right? So here tell me one thing. Okay, so tell me 14 modulus with the 10, if I do, what I'm going to get? I'm going to get remainder as 4, right? Same way, if I'm doing 7 modulus with okay, so I can say like this, or I can do, let me do it like this. So let's say here we have 2, and let me do it. Let's say here we have 10, and here plus 4, right? 10 plus 4 is also nothing but 14 only. So here I'm writing like this. So modulus with the 10, right? So here 10, I can also write it like this: 10 modulus with 10 plus 4 modulus with 10, right? So here 10 modulus 10 is 0, and here 4 modulus with 10 is 4. So here also I'm getting output as 4 only. So even if we do the complete summation and then do the modulus with the 10, then also we are going to get the same result, right? And if I do the individual modulus with the 10 of the elements, then also I'm going to get the same result. This is what I'm saying here. So here I'm just doing the summation as of now. I'm not doing any modulus for approach 2. So this is done, right? I hope this is clear. Okay, now this is done. Now in the next step, what we have to do, we have to do the summation of this, right? First, so what I'm going to get here, I'm going to get here 1 plus 2, and here how many times? Okay, let me just first write 2 plus 2 plus 3 plus 2 plus 3 plus 3 plus 4. This is what I'm going to get here, and then after that I have to do the summation of these two. So here I'm going to get 2 plus 3 plus 3 plus 4 plus 3 plus 4 plus 4 plus 5, right? This is what I'm going to get, right? And now in the end I have to do what? I have to do these two summation, right? These two summation for final. So here if you notice, let me write it in shortcut. 1 is appearing one time here, right? 1 is appearing just one time. So can I write it like this? 1 is appearing just one time, right? 1 into 1 is 1 only, right? Here 2 is appearing how many times? 1 2 3. I'm doing the summation of both, right? 3 4 4 times. 2 is appearing 4 times, so I can write it like this. Now 2 into 4 is 8, or 2 plus 2 plus 2 plus 2 is also 8. So this is also done. How many times this 3 is appearing? 1 2 3 4 5 6 times. 3 is appearing 6 times, right? And then 4 is appearing how many times? 1 2 3 4. 4 is appearing 4 times. And then we have 5. Yes, we have 5, and 5 is appearing just one time, right? So this is what we are getting right here. Okay, so here if I just want to calculate the result of this, so overall result, so 1 plus 8 plus 18 plus 16 plus 5, right? And 8 plus 1 is 9, 9 plus 18 is 27, 27 plus 16 is nothing but 42, 40 what 18, 19, 27, 27 plus 16 is 43, 43 plus 5 is 48, right? 48. So 48 I'm getting, and if I just do the modulus of this complete result with the 10, I'm going to get 8 as my remainder, right? So here if you see, output is 8 only, right, which is matching, right? But here um, let's ignore this step, this green color step as of now, right? Let's ignore this. So here if you see, this is 1, this is 4, this is 6, this is 4, this is 1. So can you recognize any pattern here? So this value, how many total number of elements here we have? Let's see. Okay, so here we have 1 2 3 4 5, right? All these values. So total number of elements we have here, and value is nothing but 5 here, right? And value is 5 here, right? And what is this? If I just do the indexing, right, here this is nothing but 0 index, 1 index, 2 index, 3 index, 4 index, right? So here can I write it like this? The last element is nothing but my 4 at 4 index, right? So can I write it like this? 4 C0, this says 4 C1, this is nothing but 4 C2, this is nothing but 4 C3, this is nothing but 4 C4, right? Clear? So here if you see, 4C0 is nothing but how we write this? 4C0, 4C0, if you study it in mathematics, so we write it like this: 4, and here we have 0, and here 4 minus 0 is nothing but 4. So this is going to give me 1 only, right? Same way if I write 4C1, I'm going to get here 4, and here I'm going to get 1, and 4 minus 1 is 3. So that is nothing but 4 into 3 factorial, and here we have 3 factorial and 1 factorial. 1 factorial is nothing but 1 only. These are going to cancel out, so we are going to get 4 only. Same way if you do 4C2 is nothing but 4 factorial, right? 4 factorial, and here we have 2 factorial, and 4 minus 2 is 2 factorial. So here it's nothing but 4 into 3 into 2 into 1, and here 2 into 1, and here 2 into 1, right? This so 2 into 3 is nothing but 6, right? Same way 4C3 is nothing but 4 factorial, and here 3 factorial and 1 factorial, which is nothing but 4 only, and 4C4 is nothing but, it's nothing but 4 factorial here, 4 factorial here, and here 0 factorial. 0 factorial is also 1, so this is going to give me 1. So here if you see, this is the pattern that I recognized here, right? 1 4 6 and then 4 1, right? So 1 4 6 4 1, here 1, right? So we are just doing the multiplication of this 1, right? 1 is nothing but this value, right? 1, 2 is nothing but this value, right? This 3 is nothing but the value in this here, 4 is nothing but this value, 5 is nothing but this value, right? And we are multiplying it with nothing but 4C0, then 4C1, then 4C2, then 4C3, then 4C4. Okay, so this is clear, right? How we are getting this, right? Now let's see this after this. Okay, this is done. Now here one more thing, if you notice here, let's see here. So what is the formula of binary coefficient, right? So we write it like this, right? So okay, so let's see here, we can show it like this 4C0 now. I can show it like this also, here 4 and here 0. This is how we can also represent this 4C1. I can represent here it like this also. 4C2 I can represent it like this. This is just another way of representation. 4 3 and here like this. Here 1 4 and 4. This is how we represent. Okay, so this value is nothing but my n minus 1 value, right? And this is nothing but I can say my I index value, right? Index value 0 1 2 3, right? So this is the formula that I have derived, right? N minus 1, here 4 is always fixed, that is nothing but n minus 1, and here I am writing I. Okay, so now here I hope everything is clear until now. Okay, so now here, now see, so this is what we have, n minus 1, and here we have I. So I can derive it like this. So this is nothing but n minus 1 ci, right? This is how we can write, and I can also write it like this, n minus 1 factorial, right? And here I factorial, and here n minus 1 minus I factorial, right? This is clear? This is clear until now, right? So this is the, let's say, my first coefficient, right? I hope spelling is correct. Coefficient. Now what is going to be my next coefficient? Next coefficient. So next coefficient is going to be here, this n minus 1 is going to be remain fixed, right, above value, and here we are just incrementing the index, right? I plus 1, right? So here this is nothing but n minus 1 c, and here I plus 1, right? And I can also write it like this, n minus 1 factorial, and here I plus 1 factorial, right? And here n minus 1 minus I plus 1 factorial. So these are going to cancel out each other. So what we are going to get, we are just going to get n minus, no, these are not going to cancel out here. See, n minus 1, and here minus, right, this I plus 1 is in bracket, right? So if I just remove the bracket here, right, so it is going to become I, here it is going to become, one second, here it is going to become I minus 1 factorial, like this, right? So now if you see, I can also write it like this here, n minus 1 factorial, right? And here I plus 1 factorial, and here n minus 1 minus 1 minus 1 n minus 2 minus I factorial, right? Now it's correct. So this is what I'm going to get, right? Now once I calculate this, right, let me use some other pen. Once I calculate this, then I have to calculate the ratio between the consecutive coefficient. I don't want to calculate these factorial values, right? So if I want to calculate these factorial values, then I have to use fast exponentiation, this concept, right? And it is also very time consuming, right? But here I am going to apply one shortcut. So what is that shortcut? So let's drive that. So for what I'm going to do, I know the first coefficient, and I know the next coefficient. Now I will just calculate the ratio, like how my first coefficient and next coefficient related with each other, like what is the ratio we are getting from moving from first coefficient to next coefficient. So what I'm going to do, I'm going to divide this next coefficient with the first coefficient, and I will calculate the ratio, right? So here this with the output that I'm getting here. So here let's do that. So this is the result that I'm going to get, right? And here I'm just going to divide it with the result that I'm getting here, that's nothing but n minus 1 factorial I factorial n minus 1 minus I factorial, right? Let's remember it. So this is done. Okay, so now here let's write it. So here you are going to write n minus 1 factorial, right? And here divide it with I factorial, right? This was there, and here I think n minus 1 minus I factorial, right? This is what we have, right? So now if you notice here one thing, we can cancel out few things here, right? So if I just write it in a good way, so here I have n minus 1 factorial here, right? And here I have I plus 1, right? And next time I can I can do one thing here. Next time it is nothing but I factorial, right? Right. So here 8 factorial is nothing but 8 into 7 factorial, like this you write, right? So same way, if I have I plus 1 here, so I can I1 plus 1 factorial here, I can also write it like this also, right? I plus 1, and then I plus 1 minus 1, that is nothing but I factorial, right? I can write it like this. So this is what I'm doing here. And here I have what I have n minus 2 minus I factorial. Let's write it like this. As of now we will update it, right? I'm multiplying it, so this value is going to come down only, right? This will remain in a down part only, that is nothing but n minus 1 factorial, and this part is going to go above, that is nothing but this I factorial, right? And here this n minus 1 minus I factorial, this part, right? This is done until now, clear, right? So now here I will cancel out few things, right? So let me use this pen. So this I can cancel out with this one, this I can cancel out with this one, right? And now here I have what I have n minus 1 minus this, right? So let's simplify it further, right? Let's write first like this, n minus 1 minus I factorial here, and in the down what we have I plus 1, right? And here I can do one thing, here, not here, let's write it n minus 2 minus I factorial only, right? Here in the top n minus 1 minus I factorial, right? So I can do one thing, I can keep it as it is, and here instead of factorial I will subtract 1 from it. N minus 1 minus I minus 1 is going to become n minus 2 minus I, and I will take the factorial of this one, right? This part, okay, this part factorial I'm taking, right? Done. So now here I can cancel out this with this one, so here this is done. So what I'm getting here n minus 1 minus I, and here I'm getting I plus 1, right? So this is the ratio I'm getting, right? I hope that you guys are clear. So this is the ratio I'm getting, right? So now here if you see from top the binomial coefficient, we are getting like this, right? 1, then we are getting 4, then 6, then 4, 1, right? So here let's see now, 1 4 6, right? Here we are getting like this, 1 4 6 4 1. This is what how we are getting, right? So here let's say if this is my current value 1, right? So in this 1, if I multiply this n minus 1, n is nothing but your 4, right? N is nothing but 4, let's say, and let's say your I is equal to 0 as of now, right? So in the 1, right? So n 4 minus 1 is 3, 3 minus 0 is nothing but 3 only, right? N is n, what is n? N is nothing but 5, sorry, n is 5, right? Total number of elements. So 5 minus 1 is 4, so 4 minus I is 0, so 4 and I 0, right? So 1, this is what you are getting, 1 into 4 into 1 is nothing but you are getting this 4, right? Done. Now let's say you have this 4, so in this 4 you are moving to the next position, right? You are moving to the next position, so your I will be 1 now, right? So I is 1, so here I can write I plus 1 is 2, and here n is minus 1 is nothing but 4, n is 5, 5 minus 1 4, 4 minus 2 is 2, so 4 n minus 1 is nothing but 5 minus 1 4, 4 minus 1 I is 1, right? 4 minus 1 is nothing but 3, right? So here you are getting 2 into 3 is 6, done, right? Now let's say we know about this 6, so using this 6 I can reach out to this 4, right? Now my I value is 2, let's say. Okay, so if my I multiply 6 with this, and is 5 minus 1 4, 4 minus 1 is 2, right? And here I is 2, 2 plus 1 is 3, so here see 2 into 2 is 4, I'm getting 4 now. So if I know this value, I'm easily finding out the next value. If I know this value, I'm easily finding out this value. I just need to multiply this with this. I just need to multiply this with this, I will get this. So this is what I'm saying, right? So I hope that this formula is clear, right? Now we will solve this problem in O of n. We will be able to solve, right? Very easy now. So you are going to see some new things in the code, like I'm going to use one what say this big integer, right? Reason is because if you calculate the coefficient of like numbers like this 99c 80, you are going to get some very big integer, right? So you can try with int long and see if you are able to pass. Definitely you will get integer overflow type errors, right? Or something, some error like this, integer overflow related, right? But or you may get a simply wrong answer in the output. But if you use, instead of int and long, if you use this term big integer, then it's then we are able to pass all the test cases. Okay, so let's write the code, right? So I'm going to do the same thing that I've explained here. Let's move to the coding part. Let me just revert it, confirm. Now see here what we need to do. So first thing is same, right? Here nums dot length, right? And now here big integer, and here coefficient. So coefficient here, initially I'm going to take 1, right? We are starting with 1, then 4, then 6, so initially it's 1 only. So here I'm writing big integer dot 1 like this, right? So here this is nothing but coefficient of n minus 1 comma 0, right? So this is what I'm writing here, right? And here int result is equal to 0. So these are the new terms for you, right? Big integer, but don't worry, it's a good learning now, right? So here after this I'm just going to run single loop. I is equal to 0, I is less than n, and here I plus plus, and here inside this big integer and the term. What is the term that I'm going to get now? So what we have to do, so first we are going to get 1 into here, if you see here 1 into this one, right? So this one is nothing but coefficient, right? So here I'm going to write coefficient, whatever my current coefficient value, I'm just going to multiply it with. So here we can simply write it like this, multiply, coefficient dot multiply. Okay, coefficient dot multiply, and here with what we have to multiply, we have to multiply it with the current value, right? This value which is nothing but 1, or you can say this value at this particular index, right? So here I'm going to write big integer dot, I'm just converting it to big integer dot value of, right? And here I'm just going to pass nums of I, right? So just like integer dot value of, when we convert any string to integer, right? So we write what integer dot value of, just like that. Okay, we are just converting to big integer, right? So this is done. So this is done. And what is my current result? Current result, you can do the modulus side by side also, right? So here result plus the term that I'm going to get here, the big term, right? So this term that I'm going to get, right? Term, and here I have to do the modulus of this term with what? With 10. So if we have to do it with 10, I can simply copy it and I can paste it here, big integer dot 10. That's it. Okay, and once I do this, I need a result in an int form, right? So here I'm just going to convert it to int value, right? So here I have to write int value, right? Int value. Okay, and then here also you can do it overall value again modulus with the 10, right? This is done. So this is how you are going to calculate the result. That's it, right? And in the end, okay, in the end you have to return the result also, right? So here you are going to return the result, but before this, so this is a current coefficient. It is not always same, right? So it is 1, then it is 1, the next time it is going to be 4, the next time it is going to be 6. So this one I have to multiply it with some value, some ratio that I have calculated here, this ratio, n minus 1 minus I into I plus 1. So this is what I'm going to do here now. So here I'm going to write if my current I value is less than n minus 1, right? Okay, until here only we need to do. So then I'm going to update my coefficient as coefficient, whatever the coefficient that I have, I'm going to multiply it with big integer dot value of converting to big integer. Okay, but this value n minus 1 minus I, right? With this I'm multiplying, right? So here this ends, right? And once this is done, then after that what I'm going to do, I'm going to divide it. So dot divide. So divide it with what? Divide it with this big integer dot value of, I'm just simply copying this and pasting it here, big integer dot value of, and here in the ratio what we have I plus 1. So here I'm just going to write I plus 1. That's it, I plus 1, right? This is what I'm going to get here. That's it, right? So this is what I have to do here, and let's run it. Now I'm just running single loop. So there is some issue, so let's fix it is on line 10. Okay, so this is the issue, this is the extra that we are using, right? So let's remove it. And also do one thing here, since we are using big integer, right? So if I just submit this solution, so let's see if we are able to get pass all the solution or we are getting any error. So see, we are getting some error here. If you see here, class big integer, location class solution, big integer this, so it's not able to find this, what is this big integer, so we have to import it. So what you can do here in this, you can simply import this java.math.big integer, right? So now let's run it. From this library we are just going to import this big integer. Okay, so now we are able to pass all the test cases, and let's see now if we are able to pass our solution or not. So see, now we are able to pass our solution, right? We are able to pass all the test cases. Now if you see the time complexity from here, so the time complexity is going to be of n now, right? So I hope that you guys are clear with both the approaches, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you in the next video. Thank you. Bye bye.